where we are now in our just looking over this again. Substance registration example. Many more that we could dive into. In the interim time, since we have other substance classes to go through, I should probably move on to the protein registration example. So we will. Before I do that, are there any outstanding questions or anything, comments that people would like to discuss?
Yeah. About abbreviations.
Yeah.
Does it handle abbreviations at all?
No abbreviations allowed.
I think, what was I looking at? The appendix for vaccine reporting, and then the abbreviations for vaccines. I was just wondering what happens.
So again, some of those might be product names like MMR and things like that, and that's really, 3 or 4 substances. And so but PV and then the strain. I mean, we do a lot of those things as synonyms. If we can map them single entity, if we keep them, it's more of a product. And if you have a lot of synonyms, and if there are standard abbreviations, they would then be considered in our system, not code usually.
But I would say, as far as this is a nomenclature issue question, I'd say certainly from the software side, you can put in any quantitative synonyms to be allowed, but I think the standard data practices be that you should really use names that are considered to be unambiguous.
Yeah, just one that title I could both spell. That's an abbreviation.
There's certainly other abbreviations that turn out to be there's too many things. Certainly we have that kind of thing. You want to put them in. So now what we have now is these and obviously for all kinds of reasons it's great to have our
national. Better to rob than a suddenly crash.
But when you include things like NDFRT and APC, then you can walk up the chain and all the facts that are connected to that. You could.
Usually just 2 names. And you can go down and down and down. We haven't done it that way, but we could. We were doing that at one point for classification where, we're doubles or triples. The current relationship now, we're going to expand it. Will be for like we call something a mediator. So like the set enzyme could be a mediator of that. But we're going to probably come up with a different model for that where we get more robustly,
So the hierarchies are in there, right? Yeah, so those being put in is the same way they're put in your system, which is sort of they're arbitrarily put in there in a systematic comments way, but there's no meaning behind them in any rigorous classification set. If that, be able to extract that information now, but the whole nature of it is not enforced. Okay, comments before we go on? Previously was submitting and registering chemical substance and being able to search for one and modify one and then do some information and so on. There's some other neat things that can happen along that way, and there's far complex examples than the ones we've given. I'm going to start actually instead to go into a second substance. I'll give you going to be what I'm going to talk about before I do it, so that everyone's in context of where things are going. The general for a protein. A protein still has those names and those codes and other relationships that all the other substances have. And instead of a chemical structure, it has a identifying information on top of them, such as sulfide bonds, glycosylation, and possibly some modifications that would happen at certain sites. So the filtration process is will be similar to what you've seen for chemicals and for concepts, but have a different set of defining elements for that one area. The protein, they would go to substance and on the drop down. And again, it would add some names. What we do, especially for quick tests, it just did quick name list. And I'll just pick one that's sort of on the edge between a small molecule, what you consider to be a chemical, and what you might consider to be a protein. The divide between the substance classes.
How do you come to name import?
I'm terribly sorry. So inside of the names list, there are the names list step. There's a single name, there's an add name list.
And the eliminated just character.
Absolutely. So the import is actually limited by character, by new line, by line feed. So we could change this to be, of course, any delimited we want. People would prefer this. The problem is with using commas, that's a common side of names very often. We're not very often new line characters inside of names. So that's why we chose that level. This is a very quick import of that. It's not uncommon for people to have a file that is also listed this way. It will consider characters to be delivered columns, so we import the first column. So that was so similar. If you just had a tab delimited file with those. So and the import function, of course, can be easily modified. So to put a list of names rather than doing them one at a time, I could put out a set of names that I want them all in. So as an example, I do stop oxytocin. Before I go on, I just want to make the point that the difference between in the system between a protein and between a chemical, as in the standard, isn't 100% clear. The number of amino acids necessary for something to be properly considered a protein or properly considered a chemical is in a well-defined area, and that's one of the advantages of having multiple substance representations, those alternative definitions. Something can easily be represented as a sequence. It can similarly be represented as a chemical structure.
For some of these acids, there are unnatural amino acids and there are natural. The representative sequence can be totally useless.
One of the things that we've done is we've been trying to migrate the data from FDA is that in all those things that look like they could have been peptides, they're put in as small molecules, and really to understand where that data is, which is important.
Or in the IUBMD, my notation were a lot of proteins, big acids.
That's when this was started.
It's going to incorporate Helm sort of in there, but again, we typically modified amino acids. Well, for E, we use a small letter basically. For everything else, we do what was called amino acid replacement, where we the total acid with another one.
So I'll step a little bit, but basically, when this was first, the idea was you have to translate the sequence as it's initially would be translated, and then you're just saying where sites have changed and talking about the change later on. It's not to say that in the future we could enter some specific modified sets, but at the moment we're just saying
Early on at that time to totally neglect microheterogeneity in protein. So oscillation, we have a broad Dutch colleagues is at group specified substance, since we are now getting a lot more information on glycosylation than we were getting 3 years ago, to actually capture that, you know, off the asparagine, at least the N-modified ones, what's the actual product glycans and things like that. But that would be something we would do at the group 1 specified substance level.
Because it's certainly an ensemble.
Yeah, ensemble. Yeah.
PTN due to memory and.
Yeah, we identify that there's sites of glycosylation. Usually for N-glycosylation, it's just by the sequence. You know, is it occupied or not? Maybe. You know, but again, we might get more detailed information now because we're starting to get a lot more of it. You know, when the biosimilar stuff come out, you know, so we may start taking it in a more rigorous way.
For many of these older INN,
Right. Yeah, sorry, Kelly. That's right, yeah.
So if I add in oxytocin, for instance, as adding, I just mentioned when the came up, after a name list, a reference will come up, and then you still have to specify what the reference is for that full set of names. So rather than going in and specifying references for every name, you can just say, here's one giant list of names, and I'm going to say these all are imported from references. Now that I want oxytocin, I can click the preferred form for name. If I for resolved structures, you'll see there is still chemical structure associated with oxytocin. Resolved structures. Yeah, you'll see what it is that oxytocin is considered to be in different data. So you can see that there is agreement on what these are. They're both put in red. So NCI and PubChem, for instance, both think that oxytocin will have associations in structure. We will just choose one of those.
Hey.
So my point is, normally, if this were a chemical structure, what would happen is we would come into chemical registration. The system at the moment notices when trying to import a chemical as a protein in order to decipher what you put in as a chemical as a protein. So in this case, it traded the chemical sequence, the chemical structure into sequence information, along with all disulfide bridges. So this is sort of me show trick before I've shown the normal way. So let me actually see if I can show you what it would look like with actually doing the import.
Quickly.
What?
Repeat quickly.
Please.
The menu you passed previously. Name. Somewhere.
Yes.
Point onwards.
Oh yeah. Well, that's great. I'm ready.
Okay, we have the other there. Yeah.
Yeah.
Okay. Editors, whatever. Yeah.
So it's preferred.
Preferred.
You don't have preferred.
No. This is common.
It's just fine. That's right. Finish. Yeah, there's older version. The word preferred for some reason wouldn't show up. So I think they're trying to display the older version than Canada. Your browser.
Yeah. Refresh browser. I refresh. Even started up the computer.
Yeah. That's a different. That's a different issue. Either word preferred.
it's the resolving of
Now, I tell you right now, I know what's important, specifically because it was being protein, and it was put in a small molecule, and I want you guys to know that. Yeah. So, I grabbed the structure and parsed it to make sure it doesn't look like.
Oh, it could be. The hustlers are so irritating. Yeah, really, that's, you come close. No.
You see that will happen if you're on the same site, you have to clear the cache.
You don't do something right, or the system is.
And not lumpiness of this demo. It's very helpful for us, and, you know, if you guys will just muscle it, then at the end of this, we'll have so many good things to work on that we'll be extremely excited, and we'll send you off.
Has to be first.
So,
Just don't write just problems.
The same result priority as well now, doesn't it?
Either solve it, or can we solve it, or we leave it
The
alone.
fact that determine it gets first.
Yeah, I think
sorry, this preferred box wasn't showing up, but if you want to this point,
Yeah, that's gonna change and be more, you know, it is a hassle, you don't know. Yeah, that's something we've noted before, so.
I should probably just mention as a general comment here. Our main purpose in this so much has been to demo and test all the data that we need to capture and in a most general sense. Now we've got to that point. From here to the home stretch is really just going through and making sure all these pieces actually come together, look nicer, and function the way that we completely want them to.
It's okay. Okay.
The point I was going to make was, if you were going to try to put in a protein, you crush it, but I'm just going to pretend we don't know that it exists, just so you see what would happen if you're starting from scratch. If you just go to the next box, and you want to start from nothing, protein is composed of amino acid sequences. There are subunits which are composed of amino acids. So in this is just one subunit. So you choose the number of subunits you want. Choose a sequence type. So in this is a complete sequence. It's not, we know it, and we know that it's not incomplete. We know exactly what it is. You can type in is the single letter abbreviations for the amino acid. Or if you click on edit sequence, so what we've done is we've entered. You click next. And our number of subunits to be 1.
Yes.
So we only have one. So in this case, I actually explain why subunits are important. So there are many proteins that are composed of several string amino acids that link together both covalently and through hydrogen bonds, right? So both through disulfide bonds and through hydrogen bonds. For small peptides, there's only one subunit. So that's, it seems maybe sort of obvious that there's one, but we always have to talk in terms of how many total subunits there are. Peptides just have.
Because the name is tetrametic column.
Well, we're capturing a lot of proteins are dimeric. If they're, insulin goes to hexameric, and, we're not really capturing that at this level. I mean, if they're covalently attached, or if they're, Tight stoichiometry, like LH, luteinizing hormone, and FSH, those are not covalently attached, but they're always together. So those would be a protein. But we're not capturing like dimerization unless it's 5-disulfide bond. Then we capture it, or I'm sure that that's the only way you get a folded protein. Yeah, but so not capturing like like a lot of times you get oligomerization of proteins. It's a research project that figure out.
Yeah, but you have to know it because when you say from an antibody,
Right.
you have to get the right strain and the heavy strain.
They're covalently attached, so they would be 4 subunits all the time.
Yes, okay.
Yeah.
But there are a few situations where they're not covalently linked, but they're always isolated together.
Yeah.
And if they're not isolated together, they're not active.
Yeah. Like Lebron's factor and factor VIII, we would capture them. Is because if there's defined stoichiometry, but a lot of times when you put proteins in solution, you get all these equilibria that happen.
I hope that answers the question of why there's one subunit and you have to say one. And first, it's for oxytocin in this example of peptide, for example.
Interested that may have indefinite stoichiometry. They are linked together, and some of the peptide may be that way. A couple of the others may.
So in general, then what would happen is if you would click on for the subunit that you've entered, you'll click edit sequence, at which point you can type in the single letter amino acid sequence associated with what you're trying to register. So this, you make up some string of letters and then see what happens. That's fine. So I'll put it in whatever keyboard.
We already have Tyler, right? Or type, or we're not the sequence yet. We haven't.
Oh no, it doesn't do it. The line as you type. So that would be an interesting thing, but probably beyond the scope.
Yeah, I talked to Trump.
So what will happen is it will immediately take out all extra characters that are not letters. So what will happen is it's surprisingly simple, but also surprisingly rare. That you'll have some string of some protein sequence that have numbers on the left or the right or spaces or whatever else. And when you try to copy and paste it into something, you have to do the really annoying work of getting all the numbers and getting all the spaces and stuff like that. I assume if there are numbers or spaces that you didn't need to put them there, it's only letters and dashes that were interpreted as being This is something to feature. Some people will copy in something and really be like, I meant to say my special dash A124 or something. But the way the data works here is it's meant to be single amino acids for the sequences.
So you have to enter the sequence in caps?
No, the point of this. So first of all, if you enter the sequence in caps and you put it and you stop it off, you'll see certain colors. If you hover any one of the amino acids, you'll see on the top some definition of what that is. This is just reminding you that this is alanine, this is cysteine. You can see O is not one of the 20 amino acids that we know, so we say this is not, we notify you from that. Similarly, what you can do if you decided to put in lowercase, I'll just put a case there. The typical way that people will do this is that lowercase ones will mean the D amino acid. So if you leave a little bit harder to see, it's the same, not just isolate. Right? Similarly, is just a very convenient choice. And previously, what people might do is better talk about what exact modification they have at that places. But the amino acids are so common that we just use lowercase letters.
Another question, does this, so let you know if you are reading protein or peptide, or is
Distinction we don't consider to be extremely important. That's your choice. It is the distinction between where that one ends and when the other begins is quite nebulous. It's about as nebulous as when it is that a chemical begins and then turns into a peptide. That's my stance, and I don't know if
That's what in the standard, that's what we call them proteins, but again, really, where's the peptides?
Well, it actually, when terminology applies to NCI, slash protein substance.
Yeah, right.
Because they're all described by the same set of data elements.
So, yeah, and this is, some of the terminology we should kind of get at in terms of what even the high level things, that there are chemicals, there are nucleic acids, polymers, mixtures. A lot of these terms, they have very specific meaning to ISO 11238, but it doesn't mean that in the English language they don't mean something slightly different. So almost all of these things are chemicals, right? Or some ensemble of chemicals, so that they'll fit there. It's just what's the most appropriate term you can get to these things. Yeah.
And it's, which way you enter the data.
Yeah, the data elements are you going to use to define it?
Mentioned, you should be able to also type in three-letter abbreviations followed by dashes, and it'll translate that into single letters for you. Often what we find is that people, for sure, peptides, they'll do three-letter amino acids. The longer ones they'll do single letter.
Typically, you're searching for a name, if you're searching for a kind of name field, find the three-letter code and a dash. Because people can read it.
So a typical thing, let me get rid of things that are a typical amino acids into that. To decide if you wanted to, you can remove a record, and also check the length up at the top. Just it's that you want to make sure that it's the same as the length you have, and nothing's been added or removed. You can duplicate that subunit if you have. This is very common to do if you have monoclonal antibodies, things like really. This is many people will consider monoclonal antibody to a mixture of an ensemble of two heavy chains and two light chains, and we do it as we actually spell out there are four subunits there. Where people might say, well, we'll just define two subunits and then somehow flag it as being monoclonal antibody. We're pretty explicit here to say that there's these two are the same, and therefore also if it turns out we make something where the heavy chains on one side is different than the other, and they have done that, then you're still allowing that to be captured. Yeah. The thing that I'll say is that after you enter one of these, you also should put in the disulfide linkages. So in the corner button, there's for disulfide. It will allow you to add individual disulfide records. So a disulfide record, a disulfide linkage is between two cysteine proteins. So in order to write them out directly down below, but what I recommend is just to click the first subunit that you like to make a disulfide link for, and hit unit. System that there's a link between. If you hover over, you'll see residue subunit 1, residue 1. That's 1, 1. And this subunit 1, residue 7. So that's 1, 7. So they're down below. You can see between 1 and 1, 7. With that and OK, then you can see that the cysteine bond has been highlighted. If you hover the cysteine bonds, you can see where it's bridged to. Like that for sequences, this is not terribly tricky to put this in. For larger ones, it can be a little harder to do. I just want to make one point here that we can start also from that chemical structure that I mentioned previously. Or simply when it started. Is that?
find your own monomer database?
So the way I get into the way that we deal with single acid amino acid modifications. In the few mechanisms to find a mono database right now, it's actually taken as being whole amino acid replacement. So to summarize what that means is amino acid is to get some identifier. That will be the chemical identifier. And then when you're saying this is a structural modification as per the standard, and then you're having that modification is placing whatever amino acid you put there.
Well, actually, the answer is yes. You use monomers.
Yeah.
Code and then you use it in the context of the monomer.
So there's no in that. So yes, there will be monomers you can use. If they probably won't, at least as in the current state, they have an explicit 3-letter code that you enumerate. They're just you're qualifying a lot more than that. So it's just like a 3-letter code in there is not sufficient. You need to say things like what the extent of the modification is, how it's done. Very often there's a lot of actual quantitative data associated with it beyond just saying we substituted this amino acid. And then
Or
it depends. It really depends.
we usually, whatever the translated or natural amino acid that something's taken off of.
Yeah, exactly.
And there's site-specific modifications, and then there's, just modifications for with so many lysines or histidines or, there's a lot of, yeah.
We can still use the resolver context in order to grab out the protein sequence as well, the amino acid sequence. So what we've done is taken the chemical structure, we've included it as an amino acid sequence, and we've pre-populated for you what this should look like. Complete sulfide bond. So that's another way that you can enter the same information. Well, stop here and then see if there are any questions or general.
That's when you make a mistake and you go back.
So
I don't know the sequence by heart. How do
you not know the sequence by heart?
Come on.
You mean, how do you do a search and a registration at the same time?
Not sure what the
Yeah, we're not searching, but like chemical and Herman, we're not searching and registering at the same time. Eventually, we will add that functionality. I hope that,
I want to
Yeah,
follow
so
you, and here, when you go back one step, I'll go back.
Means the name?
Okay.
No, not here.
Okay. There we go. And then you go on. Next. Yeah.
Really type here?
I don't know.
Taking it from somewhere else, right? So.
I don't know the sequence.
single line notation or chemical structure.
They will both. I'll show you what happened. We're back here. It's it in. It's NH2, right? Right? That's the amino acid sequence, right? Click N.
Yeah. So you have.
You actually put in that, okay. Right? You click on edit sequence, it actually takes it in the sequence.
No. George was a bit.
Yep.
We've actually tried to stay effective, species in the past, that were limited at being 999 atoms. So, which is good, bad. It's probably good because, there's a few things, there are things, but there are very few legitimate ingredients to be concerned about. They're not also proteins or new acids that come into bear.
We ran up to, fraction IN, and that's, right, 99.
It's gonna have it.
And it's not really a proton, we should have, really, the way we describe it, because there's no unity. It's like,
This has actually been one of those questions about exactly where it is that we draw them. We'll get into this more with a policy. Giant thing. Yeah. That's a lot of people actually overload the whole file and then actually just help specify the single amino acids as the atoms, which is sort of creative really, but it's probably not, certainly not comfortable with version 3000. Oh, sure.
Got it? Looking at it?
Yep. And it's disulfide. It is yeah. You're probably how you do these things.
Well, you're doing the final testing. Yeah, I know, strobe effect going on there. That's,
He's proud.
So I've actually seen this before in earlier cases. There's some browser settings where it'll try to cover browser changes and trigger this thing with decent tracking. So that's
Like, you mean,
it's a
Firefox 35?
that is fascinating. Thank you
Yeah,
for
yeah,
discovering.
All right. There.
Oh yeah.
Yes.
So to go, I don't know if there's maybe one outstanding question.
Okay. Yeah. I had to duplicate it. Let me, okay. Give me a sec.
So, go a second. The elements that we're talking about here are the amino acid sequence and the disulfide linkages. Those are the most principal defining elements. Defining element that is of importance is like the glycosylation. So for the glycosylation, it's not really relevant, but if you click that glycosylation button down below, you have information about glycosylation. So the glycosylation types, we just have a concept of a glycosylation type, and really the important thing to capture is its general distance to human glycosylation. So I haven't gone as far as to say exactly what species this glycosylation follows or anything like that. The pattern follow. At substance level, we're really trying to say, is this a human glycosylation, or is it something that's a little bit far away from human? Is it just a general mammalian level? And so
it's really determined by the cell that produced the protein, if it's recombinant, or if it's isolated from serum or from the tube. It's the organism that regulated.
But when it is CHOA cells,
CHOA mammalian.
yeah, when mammalian.
Yeah, and there was a lot of questions, and we had to do it, again, we probably cut it closer, like NS0 cells have glycosylation typically than CHOA cells. Again, when we put this together at the time, that's what, our experts in the offset therapeutic proteins thought was close enough.
So that will define, beyond just the types of glycosylation, you have to define the actual types of glycosylation. So there are three types of glycosylation. There are N-glycosylation sites, O-glycosylation sites, D-glycosylation. So for each, you can open up a little site selector, which is a little dot selector on the side. And then you can where the glycosylation happens. Now this is not really relevant in such a small peptide, but in other cases you'd be able to select them. In cases where it's predictable, we try to give you suggestions on where the glycosylation can happen, which is shown by having highlighted in green for you to click. But I like to toggle between what this site is a glycosylation site. And the last this is probably the most complex element here is the modification. So inside of modification, there are three types of modifications defined in the standard. There are structural modifications, modifications, and for proteins, it's structural modifications that are especially important. But I can hold on. Oh, I'm so sorry. Yep. Okay. Yeah. I'll just go over again what I just did with glycosylation. So glycosylation type is not relevant here for this peptide I put in. Yeah. But if you want to go into the glycosylation area, click the glycosylation button, and you find what glycosylation type is.
Yeah. And then you say N-glycosylation.
N-glycosylation. Then now you have 0 sites selected. You can click the selector over here. And now you can select where the site happens.
Yes, yes.
So I say that it happens, in this case, doesn't make sense, but if I could say it happens here or wherever I'd want to click, and then those as sites of glycosylation.
Yeah.
In dark green.
Then it goes right there, and then?
Yep. Okay, there's one site selected, and I can close.
No, two. I don't want it, but how can you store it? None? Work.
It's just toggle the buttons, toggle each one.
Yeah. I take and lysine glycosylation. Yeah. Okay, we do that. All right.
Presented one site.
Then you want to pick again. Click on these two. Next, yeah.
With this sequence.
No, there's no tool, but he gives. He should say.
You're right. We should probably tell you that warn you trying to say something that makes no sense for this.
Yes.
It's the thing. It's the now we suggest for you, but as is the general policy here, we just let you. If you say no, I'm sure, then you can go forward. But we should leave a warning.
But yeah, for N and for O, we won't let you. If there's no O to glycosylate,
then it's
glycosylation. Yeah.
There are a few examples of substances that we've tried to use where they overload the concept of glycosylation on a modified residue. In that case, you wonder whether you should be able to allow someone to select something that's there. But that's a good point, that we should probably just not even allow you to choose something.
Because you have to end the asparagine, that's the only possible way.
Yep.
But now, how to finish this?
As soon as you click it, and just click close.
You do close.
Yep, I selected some sites that makes sense.
Oh, yeah. And then you have to sign.
Yeah, one site, it tells you what the name of the site is. You do the same for O and for C. They're the same kind of thing. In these cases, there is no consensus. There's no suggested sites for N or O because these.
There's a suggested site for N translation.
Oh, no, I'm just saying there is no suggested site.
Oh, okay, in that protein, yeah.
The sequence happened to fit the criteria that you have for that. But if it had a typical glycosylation site, it would have shown you. And so on. Well, you'll see down below what the glycosylation number is, the glycosylation button. Coloring on the amino acid where the glycosylation happens will change, so that you'll know that this is a site glycosylation.
Oh, it's something else, okay. Cancel.
So going to modifications, which is really a very large concept. First thing.
You have to forge something in the past.
Yeah.
So I don't want to have to type in
You don't.
mark-based disofibrils.
Absolutely.
Yeah.
Why do you ask that question?
Waiting for you to ask that question.
Yeah.
You're not playing it, right? I didn't put you in there.
This is tool Tyler developed.
Yeah. Give that. Yeah.
Okay, now you have the Americans. Yeah.
So what we do is a typical reason, the place we have to get this information from really is from an INN sequence. There's a certain layout they would tend to have. They specify things where it is that the disulfide bridges are, where the amino acid is. The problem is that for many people, I don't know, I can't do it in there. But that for Frank and Larry and for others, actually take information and register their system. Now it's a little bit tricky to try to take this information that's put in this way and put it in there. They could put it this way, but it's a little tricky. What we've done, we just have a tool just to try to help you put that in directly. So copy and paste this from heavy chain to the glycosylation inside a record for a large protein. If you go for protein, we're still testing this out, but you copy and paste that or can automatically put that all in for it.
Yeah.
It makes things a lot easier.
Yeah. So like for antibodies, we may have a tool to
How did you come to the INN?
Oh, I'm sorry. So I just searched INN and there was a list.
Where this?
I think their list from it, from the
But then you
PDF.
switch now. You go to internet and.
I'm sorry. Let me walk through the whole thing. I did that rather quickly.
Yeah.
So what I'm saying is for import and some options you can copy and paste. See if I find let me step back one cycle, Herman, so that makes a little bit more sense in context.
Okay. Protein.
So the one simple way you can do these things, if you have things already in the format such as this, you can just copy and paste like this and it'll format it the way that you want, which is useful, but it's not quite enough. So if you can have another database somewhere, PDF, something like that, you have to just copy and paste the sequence element with or without numbers. Or else, just copy and paste that into the sequence area. So, even with the numbers and all the spaces and so on, but if you press N, it will just interpret and format it the way that we expect it to be. So I'm just stepping stones to get back to the full thing I showed just a second ago.
Okay, cool. What is it?
I mean, I'm 104.
104.
I had to choose
104.
Yeah.
And what was it?
I was gavocizumab. I have no idea if that's the way I pronounce it. It's
Okay. Okay, put down here. Yeah. Okay. Okay. Now, yes. Now, he was doing it two ways. First. Now he has to come. So the way he was doing it. Yeah, you're right.
Format that it has to buy into the
so the numbers don't matter. All that matters is just a literal string of amino acids.
Yeah.
So it's fundamentally, we don't care what the numbers are that are in there. That's formatting. We just want an actual string of amino acids. And so if someone just tries to copy and paste something in there and not that contains extra information, you just strip it out. But I would confirm that the Yep. So in this case, this is just our beta test to look for. There's a certain way that I and someone tend to write these things in text. They tend to use this prime, double prime notation with dashes, and we just look for that and then impute that this is what it should be. So I would still, you still need to confirm that what you've seen seems to correspond to it, but for the most part, we found that it's useful.
When are the, when are probably listed over here, for developing new drugs, new substances?
So I should make the point that this report, right now we're testing it to make sure that it was possible and feasible with monoclonal antibodies that are SARC, but we have to must be monoclonal to see whether that would also work. But we believe it's feasible.
Yes, so that's why I copied the times. And now,
Just one thing, is that there should be a double quote on 296.
And now, this is
So also, I should also ask for those who format the way they do things, we'd like to know how you tend to use to find your disulfide bridges and how you just tend to define side by population.
now,
My understanding, FAST will certainly allow you to use this for tagging information. Specific disulfide foam.
that's okay, that's great. Now,
I haven't seen that done, so if it is done, sure.
I mean, do it so.
I don't know if I think there might be needing overall the
Probably shows it.
first line or FAST.
Yeah, but then these are unfair, right? So
Yeah.
Yeah.
you have to enter in all the pairs. So if you go back to the list. Caught, which one did it? Yeah, it's probably added this. We should add all of these.
Yeah.
Then you add these in yourself.
Just names that will tell you that just look at it. But if you click it, you click on it, and click search.
Yeah.
See down below, just the thumbnail of that. You see that giant block of text? That's the amino acid sequence. You can double click on that record, or actually you can click on the top of the record and get to the full detail. Yes. So if you click on it, top part. I did want. No.
And I also put it in first.
Okay.
I was second, right? Or no? I don't think so, because you say,
It goes to
first is this, and then the rest.
you can see here's the amino acid protein.
Right, this is all these things.
I should ask those who know in the room, for a particular way that and those who do store amino acids, that sequences are all, there a particular way that you have to store amino acids.
You might have to make it first to print out so that you know what to do, and then, you might have.
Somebody does, nobody does.
Not relevant to me, sorry.
But as you keep track of amino acids.
Definitely. However, I realise now that there were how many, 20 or 14?
Yeah.
I didn't know yeah. But I can do that.
I'm not quite sure what happened, but I only remember 4.
Oh, that's nucleotides.
CTAG.
Those are nucleobases. Nucleic acid, this is amino acid.
Okay.
But, means one of the other.
Okay. It's a long one.
They were still there.
Yeah?
But then you use like constellation.
These are fast?
Oh, no, there's one that's not this here.
Yeah, mine, fine. Take one. So some of the, you know, yeah, I don't like didn't copy and paste stuff, so you'd have to fix it by hand. Right? Similar like
See, I wouldn't guarantee that all the Unicode are in there friendly, but there's less that in there for testing. Believe on those individuals.
Anomaly should be also.
Yes.
okay.
Sure.
Ignore the spaces. Yeah, anyway, like to go in properly. But even if you can't get it to go in properly, you just add it and verify it. Okay. Yeah. It's a big help for so many things.
And the import of the acid sequences will never fix, especially because many times the actual documents people are copying from are believe it or not, were originally pictures, and then there's an OCR algorithm that tried to bring them back. And every once in a while you'll get things like, you know, the L's will be one, and that can be.
Question. Sometimes when you have a PDF, it's protected for Control V.
Yeah.
And then you make a snapshot by the cutting program. Does you can import it from that also?
We can from an image.
Okay. You can.
Yeah.
Okay.
So I think that's a very fascinating question. And to have like a student or something work on that, I think that's a
because all the companies they put it in protective way. So that the T's are tightened.
No, yeah, that's.
I think this will kind of allow.
Yeah. Okay. So it's actually interesting. There are single character OCR recognizers where you can feed it what the alphabet it should look for. It. The biggest problem with the OCR ones on these images is it's including in alphabet letters that will never show up in an amino acid. Right? Only to say I can have L's, but I can have one. Then its resolution is very good.
Yeah.
But if you do it without that, then it doesn't tend to work quite as well.
Yeah.
It's not trivial, but it's manageable. But I will not be doing it. I actually kind of just looked at the whole what format they tend to use for I don't know. Unless there's going to be a shame. Shouldn't be I see what that is. Of course, it's no longer. Yeah, no, they're more. I'm so sorry. So far along. You're making the most important sense there ever was, and thoughts of the youth there, like. It's like so many. So libraries now.
Are the single, not used in both situations?
Yep.
And with black background, that are bridges.
That's right. Yeah, that's right. And if you hover over one, it will show you the other one is. Yeah. So I'd like to record that at 3:06, finally deranged into complete chaos. Yeah. Now to be controlled chaos.
I'm not sure if there is one save edit.
So press export. Export button, I believe. Export button.
Yeah. Save edit.
File. Up to something, if you want to call it. Yeah. Right. Right, that's right. Well, it's really great to have a bunch of very uncomfortable when we're trying this. Few people trying these things are there. Really using everything is being all in and all there that you're second. Yep. Here's the problem. It's entirely, you export it, yeah? Export it to a file. So what happens here, unfortunately, you're logged out. So just let me log you back in. So you remember your thing? You want your password? Right now, we keep that very go on for that. This was a regular. So do a quick. I think we probably. So I think we might be doing this. Yeah, we're doing tolerance and structure diversity tomorrow. We're then rotating from there into the other.
I mean, take a look at the number of substances. I like your problem, but
I think our general concept was to try to say that with those are they're fairly similar. So it makes sense to go from chemical and protein to gas. Structure really doesn't fit into anything, so that's why we have to what we have
That should be a code system for us. And I'll look at it. We haven't done that. There's some units you gotta get hold of. For targets and stuff like that, but we should make. Yeah, probably if you want to do it like a simple modification. Yeah, just how you do it. If you want to say tyrosine up there, sulfate up there.
So you would do that with the substitution, right?
Yeah, with the substitution,
Sure.
right.
So if I just get into now the most tricky part, actually I'm gonna get there right after one other thing.
Sure.
Finish our proteins for a second. There's again, as there is with chemicals, there's a lot of details that you can go farther into, especially when you get into modifications. Those can get quite complex. But just want to make a quick point that one of the things you can get into is just do some big typing, not in any detailed way, but just in as is mentioned in standard, just some general typing of what a protein is. Under the protein type area, you can see some information where you can select between what your protein types are. So whether it's a monoclonal antibody, whether it's a peptide, a toxin, or a vaccine antigen. You can subtype that relevant. You can choose between. You can choose many of them. These are conditional, but they are often useful for indexing purposes. Similarly, as I don't know, Larry, if you guys would usually consider sequence origins to be
Conditional antibodies, that's how they get be the best way to distinguish, but again, it's important to know, whether it's direct or nice or human.
Sure. So from the sequence origin, you could choose which just general categories where the sequence comes from. And then from select the substance, the structurally diverse substance, or that. So go through that again. You can choose the types through here. I wouldn't consider these to be these are probably some of the least defining parts of proteins, but nevertheless you can still there's some data there. Now, as far as to say what the sequence origin is, now the modifications become very complicated very quickly, but simple modification might be, as you mentioned before, rather than use a standard amino acid set to say this amino acid now means this, and this amino acid means this, and so on, this letter means this. The whole approach that's used here is to say that go with the translated sequence where possible, and where an amino acid covalently changes, we are replacing that amino acid with a registered chemical substance that represents the replacement amino acid. Does that make sense? To exchange one of these amino acids here with as a different as a replacement. I don't modifications. And there are three camps. There are agent, physical, and structural modifications. Structural modifications. Natural modifications. The type of modification, in this case, is amino acid replacement. The location of modification, whether this is a site-specific modification or a resin-specific modification, for instance. There are things where we just know, for instance, that all the lysine modified, but we might know in particular which ones. There are ones that we know that they're the specific or set of sites where there are modifications done to these amino acids. So in this case, amino acid replacement, I'm going to say that I'm replacing one site. So then there are the site area where I'll choose what sites are. I'll put them. And I'm the replacement. In this case, I'll say I'm doing it, let's say, at the glutamine here, one position. I selected one site to be the place of the modification. What was it? Now, amino acid replacement, specific, F14, automatically populated into this, that the modifier has to do with glutamine. Now, this is the sheer part. I'm choosing what the replacement residue is. I have this substance that represents the modification. By searching through a structure, as we've done before, or by a name. So I know. Can you give me a common amino acid substitution you might have?
I don't know, you want to do, cholesterol or something, even though typically it would be monoglutamine.
Yeah.
So let's say I was making a modification with this. Well, the way it is we draw and register this full amino acid, including the hydrogens on either side. We're saying that we're replacing what residue is, in this case glutamine, which, as Larry said, would not typically be a replacement site, but placing that with this one. I'm taking that full amino acid and I'm putting this one in. I can browse through here and then try to search for the things I want, or I can just double click down here. It will say I've selected this record. It just pointed out to me that we have this wonderful feature where if you click this, you'll be native. Don't click this. I'm being sarcastic. So if you click this top part, you'll be transported to the record, but it becomes a little bit tricky to get back to where you were. So I would recommend
Inactivate that.
Inactivate that in the future. You should only be allowed to select it. You shouldn't be allowed to
select. Yeah.
Yeah, we were putting in the important things, and now they are gone. So you should select it down below. Tell you that you selected this record. You've done a complete amino acid replacement at a certain site with a certain residue, another full substance. And specify the extent of this modification. Very often, it's just you're just doing a full. It's a complete modification. Every single amino acid has changed as it's been processed, but not infrequently, though something like 20% modified a little bit and have this little linker on it, and 30% will have such.
Or toxins, I know that on the monoclonal there's 3 toxins or 4 toxins, and they, through a cysteine or through a lysine, and we would get, the extent.
I put
specific, yeah.
So that, and then I click that it's complete. Okay. So now I have this one replacement. If I click again, structure on the sequence, a red, the amino acid where the replacement has happened is in red. That indicates that there's been a change there. Hover over that. I'll see the structure of that amino acid change, so that you can see at a glance what has been changed.
Modifications like pegylation and the toxin, again, we would handle them as complete amino acid supplement with the whole thing.
Modification would be done. Some of the modifications can get much more complicated than this.
Is there a lower weight or intolerant protein, or did you?
Yeah, unfortunately, it's not displayed here. It's displayed in the layer, to make sure that it's displayed.
So like regulated, we kept the molecular weight of the whole thing.
So it's somewhat strange in that you can actually add this to the properties part. You can choose
The properties part.
directly what the weight is in a certain context. We've sort of extended that along with polymers to be able to say that there's certain ability about what the number of ranges. But we probably allow that to come in a little bit sooner so that you can see.
Yeah.
Certainly, if adding a whole protein, then you just like with chemicals, you can go to the review screen, where you'll see at a glance all the information. The amino sequence, the protein categorization, and sulfide linkages, glycosylation, modification. I would recommend if you want to keep something,